Hello friends, today we are going to talk about from the book Databricks Certified Data Engineering Associate, a study guide. Okay, so you can read that book. So here I will going to show you the practical things of what has been explained in this book, and let's start with this. So what the Delta Lake is all about? Delta Lake is nothing but your um, table which run on top of the storage layer or storage formats. Okay, so your data can be stored in any format like Parquet, CSVs and anything, but what these data formats doesn't provide is the ACID. Okay, ACID means transactional support. Okay, or the transactional guarantee. So that brings in the delta tables, or what we call the whole concept is a delta lake. Okay, so delta lakes run on top of your data formats. It can be stored in anywhere in S3, Azure or anything. Okay, that's what the concept of delta lake is all about. And the other things that we have discussed in the last videos as well, that it provide the version control. Okay, versioning, historical, incremental load of data. So these are the things which delta lake provide. It's just a simple fancy table name. Okay, managed by the Databricks. So because they want to keep a new name to it, so that's why they came with a new name. Okay, of the table, just like MySQL and the Oracle. So they come up with a delta. Okay, so we can't call them MySQL table, we can call them delta table. Okay, and how they are managing the concurrency or transaction, that we will going to see later. So as you can see, we have this data table. So it runs in the Databricks environment. So there is a cluster which run by the Databricks, and how it going to be managed in the Databricks using the Delta Lake library. Okay, and this is a Delta Lake, and on those Delta Lake we have the Delta tables. Okay, and in the cloud storage, so while running this, while creating the tables and while inserting the data, it will going to create a JSON, JSON file. Okay, JSON file and your transaction log. Okay, so first talk about the Parquet file first. So whatever the data we store in the delta table, will going to have a separate Parquet file correspondingly. So let's say I'm inserting employee details with ID, name and age. So that will going to come under my file, which is a Parquet file having all the data. Okay, in some particular location. Okay, and plus the transaction log. So Databricks will going to create, or the Delta Lake will going to create a transaction log on each of your insertion, updation and any modification of data that will going to happen. It will going to create a metadata of thing like transaction log. So there is a separate delta log folder will be there. I'll show you, and in those delta log folder we will going to see the transaction log file. Okay, written in the JSON format. So let's talk on the other things. So how this, so let's say we have one LS and inserting the data, and there is another person Bob who is reading that data. Okay, so there might be multiple chances of the toll on the concurrency, because if one user is reading, okay, and the other user might change its value. Okay, so there will be a conflict in reading and writing. So how this delta table solve that issue is, so let's say if Alice is inserting the data, okay, with each of the data files we have Parquet files. Okay, that we have discussed last time. So let's say if I'm inserting employee details with ID 1 and the other details is ID 2, so with both the data we have different Parquet files with both the rows. Okay, so Parquet 1 will going to contain the ID 1 data, Parquet 2 will contain the ID 2 data, and this all up to the Spark who will going to manage these files. Okay, it might put all the data in one file, or it can split it into multiple files. Okay, so and the other thing is that we're going to add the transaction log in the JSON format. Okay, so at one time if we are putting all the data, so there will be only one transaction log. Next time if we are doing something updation and anything, it will going to create a new JSON file 0001, okay, .json. Similarly, if the same time if the Bob is reading or selecting it from the table, so it first read the transaction log of what is the current status of the file. Okay, if it is not changed, then it will going to read those parquet1 and parquet2. Okay, let's say if ls is made some update, okay, and Bob is still reading the data. So what happened is that updation, right? So it is updating the parquet1 file. So we know that delta tables that has been stored are all immutable. So if we can't change on the directly on the same file, it will going to create a new file. So if we are updating parquet1 file, it will going to create a new file of part3.parquet. Okay, and also it will going to add the transaction log of 001.json. Okay, so now we have 3 files, but this is already updated, not updated, I mean part1 has been copied to part3.parquet with the updated value. So this file become irrelevant. Okay, and also we have this 001.json. Okay, so what happened there, 2 things will happen. If the Bob is reading the file, okay, and if the transaction is still in between, okay, it's not committed, then it will going to read the 000.json file. Bob will going to read 000 the first JSON file, and in the first JSON file we have this parquet1 and parquet2. Okay, let's say if the data is committed, which is 001.json has been created, so this will be created after the part3.parquet will be created. Okay, then only we will going to see .0001.json file. Okay, so first this parquet file will be created, then we will going to see the JSON file. So let's say if this JSON file is already there, that means we will say that the updation or any modification has already been done. Okay, and this 001 will going to have the reference of part 2 and part 3, not the part 1, because this is become irrelevant. This is a part of the 000.json. Okay, so while reading it, it will going to see parquet2 and parquet3 file. Okay, yeah, so insert again, if we are inserting something, it will going to create parquet4, then the 002.json. Okay, and if the data is still not committed, okay, it will going to see this, it will going to read the 001.json file if the data is still not committed by the ls, and will going to return part 1 part 3. Okay, let's say while inserting there is an error still, because part 5.parquet will going to create 003.json file which is not been created. So the most relevant, the latest file available is 002.json, and in 002.json it is referring 234. Okay, so that's what it will going to show. Next concept is optimize product info. I'll going to show you everything practically, but first let's understand the concepts quickly. So why there is a need of optimization delta tables? So let's say we have multiple files, small files. Okay, so optimize will going to do is it will going to create a single file, okay, of all the small files, so that every time it won't open that file and scan. Okay, and also what the Zorder will going to do is it will create an order by ID. Okay, so let's say initially in a file we have 55 to 10 records, 1 to 99, okay, 1 and 99, 15, 50. Okay, so these are all not sorted. Okay, and also in a very huge file, it's a very huge file, number of files. So the 2 things will going to happen in the optimization. It will going to compress the file or merge the file, okay, into 2 or 3 files. Okay, and then it will going to sort those values based on the column. Okay, yeah, let's see this in a practical manner. So as you can see here, this is the by default. Okay, this is the by default schema, okay, which or the catalog we will say. So we have Hive Store as a catalog, default is a schema, and inside the schema we will going to have the tables. Okay, so this is nothing but your catalog. Hive Store is a catalog. So in the here I am not specifying any table or the schema or the database. Okay, so it will going to create the product info table inside the default. Okay, default schema. Okay, let me run this. Okay, so this is running. Okay, so it's saying user because the data has already been there. Okay, so we need to remove okay, let me remove the, because if you see it's saying in the users, where is the user, you can go to the dbfs. Okay, and then you need to search for the, sorry, yeah, you need to go in the dfs, you need to search for the users. In the user we have this Hive warehouse. So this is the default location of the Databricks, and in that you will going to see product info, okay, which is already there and contain all the files including the delta log, and delta log has JSON file which we discussed later last time. Okay, previously. So let me do one thing, let me remove. Okay, let's open the recent one. Okay, in the recent one I have the, yeah. So let me remove the entire thing first. Okay, so it's saying users, so I'm removing everything from users. Okay, now if I run this, so as you can see that we have created the table inside the default schema. Okay, catalog, schema and the table. Schema and database are same in the Databricks. So if I open the any job, okay, so table scan exchange, let me open all the jobs first. Okay, so 3 parts has been I mean 3 tasks has been created. Let me see what task it has created. Let me quickly go to the stages first. So in the stages, if you open this file has been read. Okay, you can see my Spark UI playlist, and I have explained it very easily what happened with the data. So I'm just checking this one, 3 tasks which has been created. So there is an exchange has been happened. Okay, so 3 records been read. Let me go to the streaming SQL data frame. Let's see what happened here. So there is no job ID. Okay, it's not showing you anything. So so this is optional, like while creating the delta table, this is optional. Using delta, you can put or not put, it will automatically going to create the delta table only. Okay, so let me, because we have not specified any location here. Okay, So what will happen is, let me go to the quickly warehouse. Okay, user hive warehouse. So you can see in the warehouse automatically it has created the table product info. Okay, and we have this delta log. Inside the delta log we have the JSON file. Okay, so these all will be done automatically or by default. This is the by default location of the table that you can see in the DBFS. And let me check if I can see if I can show you. So this is the same location, warehouse product info. Okay, as you can see we have this delta log folder is already there. Create for all the transactions, this will going to store the records in the JSON format. Okay, now if I want to read the content, because this is the 000.json file, so I can show you. Okay, so let me open this in the JSON pretty. Okay, now let me remove this. Let's see if it works. There's only one, but only one. Okay, one second, let me open the other formatter. See, now you can see, right? So let me close this one. Okay, so this is the username managed. Okay, all the records. Let me open it here or somewhere in the as a text. Let me open this. Okay, so this is cluster ID as managed true, because we have it is already defined the location by default location of the Spark, so that's why it's managed is true. If the location has been changed to something other external path, then this will be false. Is managed will be false. And I'll tell you what's the difference between is managed and the external table. So as same as in the Spark, if it is managed by the Spark, it will going to delete the underlying data file which is which is there in the Parquet format. Okay, if the Parquet format file path is different or the external, it will while dropping the table, okay, the underlying path not, I mean that sorry, so let's say if you're dropping one table, okay, delta table, and if it is managed by Spark, that means location is user hive store warehouse something. Okay, so while dropping the table, it will going to delete the table as well as metadata plus the file. Okay, file there in the Parquet format. Okay, when you are dropping the external table, so what happened is the table will be deleted and the metadata will be deleted, not the actual file, because file can be placed in anywhere in S3, okay, in any different SFTP location, so it does not have the rights to go there and delete it. So that's why it won't touch that. It will say if you are passing your custom location, then you will be responsible for deleting that. Okay, so its bind is true, engine, taxation ID, and this is the schema. Okay, this is name, type. Okay, so we have type, name, product name. So this is the schema. There is no partition, and what is the created time. Okay, so let me open there is one other file, let me see, .crc. Okay, so let's say if I do .crc, yeah, so .crc will going to contain the data in the binary format. Okay, let's move to the other thing. So let's say if I am inserting the data, okay, So as you can see here, we don't have the Parquet format data. Okay, so let me insert this data. There are 4 records, 1 2 3 4. So this is going to show 3 only, because this will going to keep the track of the last record. Okay, so that's why we have split it into 2. This time it is inserting 1 value, and this time it is inserting 3 values. That's why it's showing 3 values only. Okay, next move to the same. So if I'm selecting the data from the product table, it will go in here. I don't need to pass the schema. If I pass, it will be Hive store dot default dot product info. So catalog dot schema dot the table name. Okay, and let's say if I'm updating, let's say if something happened here, so as you can see, we have this 2 files got created, okay, in the Parquet format. Okay, you can read that data. So let's say I'll show you, I mean, what this data contains. This is the same. So this is basically the Parquet format data. So we have to read it to the Spark way. Okay, I'll show you later. How to read that Parquet format data. So let me open the recent one. Okay, Zorder. Okay, so how we can see the data? Yeah, let's say if okay, not this one. Let me see how I can show you reading the Parquet format, right? How we can read the, let's say this one, spark.read. Okay, so let me go back here. Okay, in the code, let me put this way in the Python, read Parquet. Okay, and what is the location? Let's say, I'm not sure if it works or not, I'm just experimenting. Okay, product info, and what was the file name? Let me copy the whole path from here. Okay, let's see if it works or not. Transaction log for delta was found at capital. Okay, let's say delta. Sorry, I think we need to pass the DBFS as well. No. Okay, I'll show you that later. Okay, let's quickly move to this one. I've showed you the content of the file. Okay, so file will going to have this thing. I'll share all the things with you, this page, so that you can run it by your own. Now I'm updating the product info price as 10. Okay, for the row ID 3. So let me run this. I will going to say the affected number 1 on this. So there is only one row for 3. Yeah, so that's why the affected row number is 1. Okay, now okay, let me open the catalog explorer. Okay, so I'll show you, I'll talk more about the this one, history table, history. Okay, describe history. So if you go to the catalog explorer and if you click on the product info from here, okay, this is the delta table created 1 minute ago. Size is this one, 2 files are there, okay, parquet 1 and parquet 2, and these are the schemas. And if I open the sample data, it will going to show me all the data. Now if I go to the details, it is type is managed by this Databricks, location is this one, okay. And now if you go to the history, okay, so these are the version which has been created, okay. So I can display the value based on the versions, okay. So if I want to see the previous value of non-updated values, what I mean, if I have changed the price to 10, okay, I want to see the actual price or the before price, what was that. So I can quickly check using the versions, okay. So version is a write where I have inserted the data, because 2 times I have inserted, that's why you can see this 2 rows are there. In the third version I have updated it, okay. So I want to see the previous value, which is 2, I can quickly see that, okay. So if I go here and if I see with the product ID 3, the price was 29, okay. Now I change the price as 10, okay. So if I show you, so product ID 3, it should be, the price should be 10 now, okay. And this the other ways to show to see the history is describe history product info, okay. So if I run this, it will going to show me the same value which I have seen in the catalog explorer, okay. Yeah, with other fields as well. So there is a timestamp where when the new version was created, this is the version IDs, okay. So there are 3 ways basically if you want to see the previous version. First one is the as of, okay. So using as of, so there will be column name and the column value. So let's start from product info, timestamp as of this one, let's say as of this one, okay. So in this timestamp, this is the first one, okay. So in the first version I have inserted only one value, so that you can see, okay. In the other version I have created the other 3 records, so that you can see basically 4 details, okay. Now the other way is, so this is the column number and this is the value with as of. So version, if I want to see the version 2 value, so version 2 value would be, yeah, for 3 product ID the price is 29, okay, for version 2, but latest version is 3, okay. The other way is @v2 or v3. So if I query v2 version 2, it will going to show me the price for 3 as 29. If I do version 3, the price should change to 10, okay. So as you can see now, okay. Now the other thing is delete from product info, okay. So if I delete this table, where is the vacuum, okay, I think, yeah. So let's say product info, yeah, it should come up first here. So let's say if I'm deleting that table and if I want to restore my table again, okay, let's say if I have deleted the table and if I want to restore that again, as of which version, that also I can do, okay. So let me run this. Let me delete the table first. So now there is nothing, there should be nothing. Okay, so let me quickly see sample data. Okay, yeah, the underlying data is already there. Okay, so delete from product info. Okay, so I want to restore this table to version 2. Even if we deleted the table, it has not been deleted. Okay, so we can restore that table, and let's say if I query, I can still see the data. Okay, let's say if I'm dropping the table, okay, so this table is not there. Let's say what about the data? Okay, so there is no data as well, which has been deleted because I have dropped that table. Let's say this restore works or not. Okay, because the table is deleted, the restore will not going to work. So let me quickly create the data table again. Okay, and let me insert the data also. Okay, the product info. Okay, so product info has been created now, and if I run the insert statement there, okay, so now we can see the data has been inserted, and yeah, so delete does not work. Okay, it will not going to delete the table. So we can quickly restore that data, and yeah, so we were talking about the schemas, right? So by default we have default one. We can create another schema dbx. Okay, so this schema will going to be created dbx, and inside this dbx we can create the table. So before that we need to use the use dbx and then the table name. Okay, so we have this new table under dbx schema. Now what we want is we want to delete the table, or not the table but the underlying data, okay, which has not been used. So for that one we have this vacuum, and we can use a 0 hour. Okay, 0 hour means it will going to delete the archived, okay, which has not been used by the Spark or the Databricks. So those file will going to be deleted. Okay, so we do have, let's say, dbx hive meta store. Okay, So this vacuum don't know why it's not working. So the concept behind this is vacuum protein for table or dbx cannot be found. Okay, so this has vacuum protein4 underscore. So if I go here, okay, user data warehouse, in the data warehouse we can see that dbx.db protein4, okay, and in that protein4 you can see the protein4 underscore and there's a delta log. Okay, so with this vacuum what it will do is we can do retain 0 hours. Okay, so whatever the data it's already had, okay, internally, I mean the parquet file will going to delete it. Why 0 hour? Because we want to delete it immediately. If I am going to put it 1 hour, then data older than 1 hour will going to be deleted. So mostly it's 7 days, by default is 7 days. Okay, 7 into 12. Okay, so these many hours it will going to retain that file. Okay, the data which has not been used, after this hour it will going to delete those records, because as you can see we have part 1, part 2, part 3. So part 1 was not being used, okay, in the recent version, current version. So that file that going to be deleted when we run this vacuum. Okay, so I hope you like that video. We have the other things as well coming in the other video. Comment me if you want to see more videos. Okay, yeah, thank you.